Hi, everybody. Let's talk about evaluating and working with radicals today. To get you started, if you go into your Google Classroom, there is an activity for you to do through Desmos. Okay, so go into Google Classroom, try the activity with Desmos, and then once you're done with that, come on back here to kind of sum up what you should have learned. Okay, so we have what's called entire radicals and mixed radicals. So an entire radical means that the whole number is underneath your root sign and there's no number out front. Whereas a mixed radical will have a number in front and a number under the root sign. So each one of these are considered to be entire radicals. We want to change them into a mixed radical. So to do that, I want you to think of two numbers that multiply together to give you 27. One of those numbers is going to have to be a perfect square. So our perfect square numbers are like 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on. So those are the numbers, of course, that we can take the square root of. We're looking for those numbers. So two numbers that multiply to 27, and one of them is a perfect square, could be 9 times 3. 9 times 3 is the same thing as 27. And then we can break up this radical into two radicals. So the square root of 9 times by the square root of 3. And then we can actually find the square root of 9. We know the square root of 9, it's to be 3. And so this is how we've gone from an entire radical into a mixed radical. It's like you're partially taking the square root of part of the number that's underneath. Let's try another one. Square root of 50. Square root of 50 is the same thing. Two numbers that multiply to 50. One's a perfect square. Is going to be 25 times 2. 25 times 2 is 50. And then that's the same thing as root 25 times root 2. And of course, the square root of 25 is 5. And so the square root of 50 is equivalent to 5 root 2. All right, 72. What two numbers multiply together? One's a perfect square that equals out to 72. Well, hopefully you were thinking about 36 times 2. 36 times 2 is 72. The square root of 36 times the square root of 2, if I break this into two parts, and 6 root 2 is my equivalency. So the square root of 72 is the same thing as 6 root 2. Okay, I want to show you, just for interest's sake, what if you had picked the wrong numbers? So what if instead of using 72, I said, well, that's the same thing as 9 times 8, which it is. And so that's the square root of 9 times the square root of 8. And the square root of 9 is 3. Oops, 3 over root 8. 3 times root 8. Sorry, I'm a little messy here. Okay, so obviously not the same answer. And this is a mixed radical, but it's not the one in simplest form. We can still find the square root of 8. I can still put that, simplify that further. So we know that 8 is the same thing as 4 times 2, which is the same thing as 4 root 4 times root 2, and the square root of 4 is 2. And notice how I put it in brackets. And I'm putting it in brackets because it's going to end up being multiplied to that 3 out front. I don't want you to think the number is 32 now. It's not 32. It's 3 times 2, so 6 root 2. And lo and behold, it's the same thing as what we had gotten over there. So if you don't pick the largest perfect square number, that's okay, because you can still simplify it further and keep going. All right, Now, adding and subtracting radicals is the same as adding and subtracting in algebra. What you're looking for is like terms. Now, like terms in this case are not going to be the same variable, but instead they're going to be the same number that's under the root sign. So looking at A, we have 3 root 5 minus 6 root 5 plus 8 root 5. Root 5 is my common term, right? So that's what makes these like terms, is that we have that root 5. So all I need to do then is to start with 3 root 5 minus 6 root 5 is going to be negative 3 root 5. And then plus that 8 root 5. So altogether it's 5 root 5. Notice that the root 5 does not change, okay? So when we are adding and subtracting radicals, just like with algebra, the variables stay the same. In this case, the radical stays the same. So the root 5 does not change, but we add or subtract the coefficients in front. Let's try another one. Oh, so this one, by first glance, tells me that I cannot simplify it at all. But let me change these from entire radicals to mixed radicals and see what we get. So 12 is the same thing as 4 times 3. So root 4 times root 3, so 2 root 3. And 48 is the same thing as 16 times 3. Which is the square root of 16 times the square root of 3, which is going to give me 4 root 3. And now, if you look at this, I have 2 root 3 plus 4 root 3. I have that common mixed, or that common radical. I can add these together, so 6 root 3. So if you notice that your radicals are not the same, so you can't add or subtract them, try to simplify them first. Change them to mixed radicals, and then from there, see what you can put together. Oh, this one's a big long one, so I guess I'll put this down here at the bottom and move my board up. Okay, so root 5 plus root 50 plus root 20 minus root 98. Oh, okay, so I don't see any of those that are the same, so it looks like at first glance we can't combine any of them by adding or subtracting, but let's just go ahead and see what we can do here by changing them into mixed radicals. So my first one, the square root of 5, is just going to stay as the square root of 5. I can't simplify that further, but the square root of 50 is the same thing as 25 times 2. 25 times 2 is 50. 20 is going to be the same thing as 4 times 5. And 98 is the same thing as 49 times 2. So look at that. So square root of 5 plus the square root of 25, which is 5, and then root 2 stays. Square root of 4 is 2, root 5 stays. Square root of 49 is 7, and root 2 stays. And now I can combine my like terms. So root 5, even though there's no number in front, it's considered to be a 1. So 1 root 5 plus 2 root 5, which is 3 root 5. And then 5 root 2 minus 7 root 2, which is going to be, a minus. I jumped ahead and put a plus there, and I shouldn't have. Okay, minus 2 root 2. All right, that was fantastic. Okay, last one. Let's take a look at D. Ooh, another big long one. Now, the reason why this one, we're going to do this one, is because we have these numbers out front. So we have leading coefficients, and I want to show you, again, we had looked at it on the previous slide, but just a reminder of when you have a coefficient out front, what you do. So 3, now 28 is going to be 4 times 7. 200 is going to be 100 times 2. 63 is going to be 9 times 7. And 50 is going to be 25 times 2. Okay. So The square root of 4 is 2, so I'm going to put that 2 in brackets beside the 3 that's already out front. The brackets reminds me that I'm going to multiply. And then the square root of 7 stays. Plus, square root of 100 is 10, root 2 stays. Plus 4 bracket, square root of 9 is 3, root 7 stays. Minus 5, square root of 25 is 5, in brackets, root 2 stays. So by simplifying the radicals, we're going to end up with these two numbers that are in front, but we're just going to multiply them. So 3 times 2 is 6, root 7 plus 10 root 2. 4 times 3 is 12, root 7. And then negative 5 times 5 is negative 25, root 2. Okay, so these are going to go together. And these are going to go together because they have their common radicals. 6 root 7 plus 12 root 7 is going to be 18 root 7. 10 root 2 minus 25 root 2 is going to be negative 15 root 2. There we go. Whew. Okay, so adding and subtracting is just like algebra. We have to make sure that we have our like radicals in order to put together. And then the big thing, of course, is like what we just did in D, remembering if you already have a coefficient out front and you changed your radical to a mixed radical, then that number that you take out, of course, has to be multiplied by the number that's already in front. Okay, so multiplication. Multiplication with radicals. Same thing with algebra. When you have something outside of the brackets, you want to multiply to every single term inside the bracket. So our distributive property still works, still doing that. When you multiply radicals, what's underneath your root sign, they get multiplied together, and what leading coefficients, they get multiplied together. Okay, so again, just like algebra, just like your variables, you would multiply variables together. And just like leading coefficients, you would multiply those together, same thing. So root 2 times root 5 is going to be root 10. Root 2 plus root 7. Root 2 times a positive root 7 is going to give me root 14. And looking at those two radicals, I can't find a number that would multiply, two numbers that multiply together, and one of them is a perfect square in order to simplify this. So then I would stop right there. So root 10 plus root 14. Okay, so here's what I was talking about with coefficients, leading coefficients and radicals. So you're going to end up multiplying, let me just do this in a different color. You're going to end up multiplying the 3 and the 4 together and the root 2 and the root 3 together, okay? So numbers to, like coefficients to coefficients, radicals to radicals. So 3 times 4 is 12. Root 2 times root 3 is going to be root 6. Same thing now with the next one. We're going to go 3 times 6 and root 2 times root 8. Okay, so 3 times 6, which is 18, and root 2 times root 8, which is the square root of 16. Once you're done, stop, take a look, and try to figure out if it can be simplified anywhere. There are not two numbers that multiply to 6, one of them a perfect square, so that just stays as 12 root 6. The square root of 16, I can actually find the square root of 16. The square root of 16 is 4, so that means I'm going to multiply that 18 by 4, and 18 times 4 is, I think, 72. You might want to check my math on that, but I think it's 72. All right. Okay. Now, we can even get into binomials. So we're going to multiply two binomials together. This is our distributive property again. FOIL, right? So we're going to multiply our first radical by both radicals inside the second set of brackets, and then our second radical by both terms inside the second set of brackets. Okay, so let's go. Root 3 times root 10 is root 30. Root 3 times root 7 is the square root of 21. Root 5 times root 10 is the square root of 50. And root 5 times root 7 is the square root of 35. All right, from there, we take a step back and we see if we can change any of these into mixed radicals. So square root of 30, I'm looking for a perfect square number that would multiply to 30, and I don't think I can think of one. So what multiplies to 30? 1 and 30, 2 and 15, 3 and 10, and none of those can change. So that's going to stay there. 21, so 1 times 21, 3 times 7, none of those are perfect squares, so I can't simplify that. 50, well, we've done 50 a whole bunch of times, so I know that's 25 times 2. And then 35 is going to be 1 and 35, 5 and 7, and that's it. So it's going to stay as the square root of 35. So root 30 plus root 21 plus 5 root 2, because the square root of 25 is 5, plus square root of 35. And from what I can see, there is nothing there that I can put together. So I just stop. Can't continue on. All right. Let's try another binomial again. So same thing as before. We're going to take what's outside, what's first in our brackets, and multiply it by both terms in the second, and then our second term, and multiply it by both terms. And what I end up with is root 3 times root 3, which is going to be the square root of 9. Root 3 times 6, which is going to be 6 root 3. Notice, because it's not under the radical sign, that it's what we call a leading coefficient. So it just gets, it's like this has a 1 in front of it, the root 3. So it's like multiplying 1 root 3 by 6, so 6 root 3. Same thing over here, negative 2 times root 3. That's like there's a 1 out front, so negative 2 times 1, which is negative 2. Root 3, and then negative 2 times a positive 6 is going to be negative 12. Okay, so we can keep going with this. The square root of 9 is 3. Plus 6 root 3 minus 2 root 3 minus 12. And lo and behold, not only can I put my constants together, so 3 minus 12, which is negative 9, but I can also combine my middle terms, which is going to give me a positive 4 root 3. Awesome. So that one definitely simplified up a whole lot better than what the one did before. But that's because both of those brackets started with the root 3, and then both of them ended with those constants. So I kind of knew it was going to simplify to something better. Okay, so when we're multiplying, then all our rules still hold true. You take what's outside and multiply it by everything inside, or if it's binomials times binomials, you make sure that you multiply your first term by everything in the second set of brackets, and then your second term by everything in the second set of brackets. We always look to try to simplify at the end, change those entire radicals to mixed radicals, and see what we can combine. Remember, we only multiply leading coefficients with leading coefficients and radicals with radicals. All right, the best way to get used to this stuff is to practice. So page 39 in your book, if you can just please go there and hopefully find those questions and give them a try. And then let me know, of course, if you have any problems. Thank you.